All right. Yeah, so just symmetries today, or at least we're starting with that. So yeah, let's just get started. I think I have to sneeze. Um, or maybe not. Okay, wiggle the terminal, make sure everything's working. Okay, CD into BumperCoins bot. Status. Yeah, I pushed that last thing off stream. Hopefully finished. That's what we did last time. Convert policy to tensor. And then we talked about what did we talk about? Symmetries, which we're about to do. So yeah, symmetries, right? Let's make this full screen. And then let's see what file we were looking at last time. Symmetry, right? So like for connect4, this is a CF in connect4's directory. Parent and connect4, like this connect4 sibling directory. So we have symmetry. So symmetry again, like these three operations were like this operation and this one, the first and the last operation are used in Monte Carlo tree search when we're kind of like querying the neural net given the game state, like, hey, like give me the value and give me the policy. So like to get the value, we just kind of transform and pass it in, then boom, we get our value. Then our policy, the policy we get is actually P prime. It's the policy for the transformed game state, S prime. So we have to kind of recover the original policy, which we actually wanted to begin with. So that's why we need this. And from P to P prime is we need that when we're actually like training the neural network to generate to do data augmentation, to create more training data, to make the network more robust and like invariant to various transformations. So identity, very straightforward, gs.clone, p. So we need a policy.clone too, okay. Okay, so let's get started. So basically for connect4, the only kind of symmetry we have, like that's interesting is like this symmetry right here, the horizontal symmetry. So we have to kind of do horizontal, vertical, and horizontal plus vertical, and of course identity. So wait, do we have a policy.clone? Let me check if we have let me just see our policy file. In our policy ts. Do we have a clone? Yeah, we actually have a clone. So like how does this clone work? It uses move.clone. Copy like the move number, and then basically what it's doing, like number we can just directly copy. It's not like an object. But this one we have to have move.clone. So as long as this function right here works, then policy.clone is given to us for free, right? Because we just kind of are leveraging move.clone to get this to work. So let's kind of like look at our move.ts. So we have a clone here. So we kind of copy the coin ID, copy the move ID, and then we kind of do the nested, like the fixed point clones of the velocities. Okay, yeah, that gives you a deep copy. So that's good. Everything's in order. Get status. Okay, so now let's actually like kind of let's call that symmetry c4.ts. Status. Great. Okay, this looks good. Let me drink some water. Okay. So let's kind of create a new file, symmetry.ts. Whatever. Okay, so let's delete the cell nonsense because we don't care for that. GameState policy move. Okay, great. Good. So let's look at symmetry. Symmetry like takes the transform GameState function, which kind of is a lambda. It's a function that takes in the GameState and returns the GameState. Transform policy again, and then policy to policy. Inverse policy, policy to policy. Constructor, just those three things. And then like the methods it kind of supports or offers. is basically just kind of a wrapped around, like uses its internal thing. So the API, it exposes these three transformations. The way it exposes them is just calling its internal member. So yeah, actually we can just kind of copy the whole thing. So that there's nothing wrong with that. And the only classes that it uses are GameState and policy, right? So the only imports that we care about are GameState and policy. So move comes later because move is kind of a part of move, and I guess cell in this case were kind of more like the implementation details of the actual like flipping horizontally, the actual transformations. But the high level symmetry class doesn't concern itself with those details. Those will be like whatever we're passing in the constructor, the lambdas, these transformation functions, like those are the ones that care about cell. So that's kind of particular to C4, Connect 4, but like here, like the transformation, we don't have any cells. It's fixed point. Anyway, so we kind of copied that file. So let's just kind of paste that there. Great. So we have symmetry. That's good. So now what? The identity symmetry, right? The identity symmetry, I think we can just copy that directly because like all it's doing is it's cloning the game state. And it's like cloning the policy and then same thing, cloning policy. So like there's nothing kind of like we just checked that policy has a clone method, which is true, and then GameState has a clone method too. So I think we're just like we get that for free then, right? Like nothing too crazy there. And now for the actual work of like doing flips. I think it may be beneficial to open up the GameState file. Okay, so how do we flip the GameState horizontally? So this kind of comment, oh, my neck hurts. Okay, so this kind of like, okay, so let's kind of, first of all, we can use this. So we have flip game state and we're going to eventually return that. So now the question is like, how do we actually flip it, right? So first thing we do is, yes, we set the turn. Basically this flipped stuff is actually a lot like the clone function, right? So, okay, time to go to our whiteboard, right? Our good old trusty whiteboard. 31 minutes, okay. So we're right now like kind of doing this thing right here, the state to the state. We're not caring the hours. We're just kind of like, so given a coin's position here, how do we get like the coin to go there, right? That's just like 20 minus this length here, like this length from the center of the coin to this wall, same as from this one to this one, right? So like if this is like the x coordinate, then this coordinate is 20 minus that original x, right? 20 minus that x. Okay, so let's undo these changes. That's pretty straightforward. So that's just 20 minus that, right? Which should be quite reminiscent of like Connect 4 is like 7 or 6 minus, like the number of columns minus like that whole thing right there, right? So now let's just kind of see what clone does. Actually, yeah, why are we making a new one? Let's just do a GameState.clone, right? What's the point in making a new one? That's just stupid. Or gs dot clone. Let's look at clone. So here's clone. Clone, we first create a new game board, then we have coins, wins, obstacles, and for each of the coin, what we're doing is we're kind of creating a new coin, and deep cloning the fixed point its own like coordinates, and these are like separate objects now because of fixed point dot clone. And then what we do is so we kind of do that, and then we just do that. Okay, so that's same thing for wins, and same thing for obstacle. Even though obstacle technically there's no need because it's only like fixed obstacles which we never really mutate. Like obstacles don't have any health in them currently. And then we just return a new copy of them. So yeah, so we can just kind of like do that. This kind of idea, we can just clone it. And we make sure to set the turn. Is P1 turn, we set to we have to do that there. It's crucial that we do gs.p1 turn, not like itself. So that's gs.p1 turn, which is correct. So what other fields are there gs? Like the number of those are static. The prev game state. So clone takes into that count that, right? Oh, clone does not. Okay, we have to fix clone then. Yeah, clone should set the clone has to set the turn status. Yeah, let's see how clone. Let's refresh. Let's see how BumperCoins clone does it. Yeah, is P1 turn is this dot P1 turn, right? Let's copy this line. Okay, so clone now kind of, and it has to do the prev game state too, right? Just like this, right? So copy should also kind of do the Oh yeah, that's a very interesting question actually. When we're transforming the game state, oh. Okay, so this actually raises an interesting point about previous game states. Not only do we have to do the transformations for our game state, but we'd have to also do it for the previous game state as well, right? I did not think about that. Game board, coins wins obstacles is P1 turn, and that's full. I guess technically we should copy these ones too, right? Even though it doesn't matter. No, it's the clone, right? Fixed point dot clone. Oops. Okay, so yes, so now we kind of like added. So basically, what I did is like I added extra like we kind of like stored like the clone is the copy, right? It's what we're gonna return as the cloned. So whatever fields are there on GameState, like these fields, although well technically the non-static ones, I just made sure that like all of these are populated correspondingly. Like first we were only doing coins, wins, and obstacles. We forgot to do this. And I just did these energy things too, even though technically like I don't think the energy is ever been required except like in the physics code, which like decrements the energy or something based on the intensity of the launch. Or wait, no, apply move does that, I think. Yeah, I'm not sure these fields are even needed. In fact, maybe I could just remove them. But I don't know. Actually, yeah, let me actually look at the usage of GameState.p1 energy. Oh, okay. Sheila, let me see a GameState again. Let me look at GameState's apply move again. Like, does this like involve energy anywhere? No, it doesn't. Okay, let's just delete this energy stuff because like the whole point of this like turn-based abstraction is we don't care for energy anymore. So let's clean that up. No need for energy nonsense. It's turn-based. There is no energy. Yeah. Okay. Like sometimes like stronger moves consume more energy than weaker moves. Weaker moves consume less energy. So like, but now all the moves are fixed at 0.4. So like energy becomes meaningless. The whole point of the energy is however much energy is consumed in a move is 59 point something. That's what we calculated, which like rounds up to 60. So like because like we kind of advance 30 ticks, then let the opponent play, and then 30 ticks. That means 30 plus 30 is 60. So 60 ticks pass, and 60 is strictly greater than 59 point anything, which means by 60 ticks, the energy is back to being full. So yeah, there's no need to even concern yourself with any energy fields entirely. They shouldn't be used at all. And yeah, physics code does not actually take into account energy. Energy system is actually I added energy system after adding like it was an addition. Like there wasn't always an energy system. This was more for like I felt that like the game itself, it kind of like favored like a very aggressive gameplay, where like there wasn't much strategy, and like the energy system kind of like helped make the game more strategic. Cause like you have to make your moves count since there's only a finite amount of energy with like a cooldown period. Like you can't just spam a bunch of moves and like go all offense and no defense, or just kind of like hunt the opponent's king. Then whoever has like a better mouse skills but lower ping will just win. So that's kind of one of the motivations behind the energy system. So anyways, but I'm saying that since it's now turn-based variant, like which we're coding bots for, like there's no need for the energy field, so I deleted them. Okay, so now the whole point is like so here we're like copying the pointer directly. So like the clone points to the so like the clone points to like the same thing before. So let's consider Monte Carlo tree search. So like we're given a state, and then we want to take a move, an edge. So then what we're doing, I know I've drawn this several streams ago, but I'm just refreshing myself, my memory. So we have a game state, and then we choose like a move to make. So then we what do? We just we clone the state because we don't want it to apply move as a destructive operation. So we clone it, which means like the pointer still points to whatever the previous state was. And then we when we're so like we clone it, but then we kind of destroy it by applying the move to it. But then apply move also takes into account like the thing that we cloned and sets the pointer, right? Like apply move also takes the next previous one. Exactly. So that's how. Okay, so then for symmetry. So for symmetry, what do we have to do? Because like how do we transform the game state horizontally, but we have to transform like the previous game state also, right? The previous one as well, and like based on like the dynamic, like yeah, okay. So I think what we have to do right now is open up net.ts. And let's export this constant, right? So we just do kind of, or how do we kind of export a constant? Export, and then the variable name, the type. Okay, got it. From net.ts. Kind of like this, right? Where we're kind of like advancing, like doing it for all, like we have to like transform the coins, like basically like this kind of transformation operation from like this coin kind of goes here, like kind of just like flips about the vertical midline. Like this coin kind of flips here and this coin flips there to form this one. we have to do this for this game state, but also for like the past k game states as well. That's why we need this loop here. So cur game state now is the same thing as the flipped game state, right? The flipped game state. And then for each of these times, num game states we imported, which is 2. Then for each coin in game state.coin, how do we actually like do the flipping, right? So then this whole stuff here gets deleted with our own code. Flip coins x to 20 minus x. Or whatever this thing is, number of calls minus x, right? That's kind of like the idea, and then we just kind of advance it like that. Okay, so that's fair enough. Now there's an optimization where like if this is true, then like we do this, or else we just kind of break out of the function because any future thing is redundant. But that's not a big deal. It's not a big deal at all. Okay, so now let's just do this, right? So now how do we do this? Let's kind of, I want to kind of look at fixed point, but anyways, yeah, let me just kind of open up fixed point. Symmetry.ts, GameState. Or fixedpoint.ts. Or actually, yeah, never mind. GameState.ts, and let's just do fixedpoint.ts now. So what do we have here for fixed point? We have a clone, we have equals, like where's subtract, oh, there's a sub, negate, that's nice, where's sub? Subtract. Okay, fixed point dot sub. Dot sub of this, right? So fixed point sub a comma b does a minus b. Okay, got it. And this is game state. So okay, these comments I think we can kind of get rid of. So okay, coin.x equals fixed point. Wait, we have to import fixed point, right? Just like that. So let me do it. Let me import it after there. Dot sub. Something like that, right? So then rather than doing like 20, it's GameState.num calls, right? Okay, just like that. So for the coin, so first we'll say, okay, so flip game state horizontally. So given a game state, how do we flip it? We first clone the game state. So the flip game state is a function whose type is a function that takes in a game state and returns a game state. So it's a function that takes in GS and returns the game state. So GS is just our input state. So first what we do is we clone it. So that means that we can kind of like muck around with it. Wait, hold on. Okay, no, this is a bug because these transformations which we're doing, we're kind of stomping over, like we're kind of mutating the previous one. Okay, so this is wrong. Dot clone, right? Okay, I have to be very careful here. I have to be very careful here. So here's what we do. If that, or else we just kind of, we can just break it. Okay, so then, okay. So let, prev GameState clone equals, or actually GameState of type GameState equals this, right? And then what we want to do is we want to say that cur game state.prev game state is now going to be equal to not the original one, but points to the new clone. Does this work? Okay, instead of flipped, let's actually kind of do something different. Let's change it to cloned. Yep, change that, change that, change that, change that. Okay, good. So now we have cloned game state, which is kind of a copy. So the only kind of danger is the previous pointer. So then, and then wait, there's no need for this line for you. That's kind of redundant because cloning already takes care of that for us. Okay, so then we have a current game state. So we have this current game state, which is, or rather than current game state, let's call it current cloned game state. Cur game state to cur cloned game state. Cur cloned game state, cur cloned game state, clone game state, clone the game state, cur clone the game state. What? Actually, let's just call this prev cloned too. And of course, now the cur cloned game state equals this then. I have to use the restroom, so I'll be right back. And then I'll look over this again. Okay, so where was I? Right. Cloned GameState. Cloned GameState. Cloned GameState. So then, if you have a previous one, so then for like, so this is 2. That means from K from 0 to 1. So then from K0, we just kind of, for the current GameState.coins, we just like, it's a clone, so we're okay with kind of doing a destructive operation on it to 20 minus itself, so that basically flips it horizontally. And then what we do is we advance the game state to prior, so now K is 0, and then we do this, and then K equals 1. So then K is 0, we flipped all the coins in the current game state, which is this one right here, a copy of this one. But then we kind of like consider the previous game state, and again, cloning it would mean that the previous game state is the same as this .prev. They point to the same object, so what we have to do to not destroy, to stomp over that, is we have to create a fresh copy of the previous game state. So that's what this is. It kind of clones, it takes a clone of that, right? It clones that, it copies like everything, so that means we have a new set of coins to work with. And then what we do, what are we doing here? So we have that, and then what we actually, let me just not look. So we did this, and then what do I want to do? So let me kind of close my eyes. So we clone the previous, and then we want to wait, so we point to the previous of the old one, we make a copy of it, and just bind it to that. But I know I have 2 lines below, but I can only see 1 line, which is we just like, oh wait, no, I get it. So what we do is we take our clone state, and then we kind of set the back pointer to the thing we just cloned, the clone previous, and then we kind of advance it by setting the cur clone to pre-clone. Okay, yeah, perfect. So then this is what we do there. We take our clones and we set the previous state, like, because like again, like this thing currently points to like this thing.prev, but now what we do is we set it to point to the clone of that, and then we do the advancing. And the advancing is right here. This is the line that actually advances it. It sets the new current to the new clone. So like the cur clone, prev clone. So like this, like current prev and cloned game state clone. Okay, game state clone seems stupid. Wait, what? Prev clone. Wait, this sounds very dumb. Wait, why is it called prev game state cloned? Just like that. Okay, so that looks good. Okay, perfect. They have to do the same thing vertically. Or actually, what we can do instead is we can make a general function. Yeah, we can kind of make a helper function, right? Because when we do the same thing vertically, right? Like this is flipping horizontally. We'd have to kind of copy this whole function and then only replace this logic here. So instead what we can do is like make this a general function. So it's like a flip or transfer or make transform game state function, like this thing right here. Game state function. So then what is this? So this is a make function, and that's its return type. This whole thing is the return type. what we need to transform is this thing right here. It takes in a coin, right? Coin. No, it takes in a function. Like that. So that's so the output. So this right here is the return type of this make transformation game state function. So it generates a transformation game state function which takes a game state and returns a game state. So that's fair enough. But then this thing, the input is itself going to be a function of a coin and something else. It takes in a coin and it will return a coin. Or wait, no. No, wait, TypeScript. Just void void. So we kind of we're currying it in, or wait. So then we kind of take this. And what we're doing is we're kind of like taking in like a function here, which takes in a coin, the transformation function. Oh, we have to fix the signature here too. Hold on, I'm a bit confused. Okay, so actually, no, let's fix that signature first. So this is a function that takes in a coin. Let transform game state function equals that. Like that, right? Something like this. Something like this, right? So now what we need is a function like that. and its input type is this. Why do we have these brackets? Let's delete these brackets. Let's add a space here. This looks kind of ugly. Oh wait, no, we do need those brackets, I think. TypeScript. Yeah, currying. So adder. So add is a function. So then add, like, so add is what? So if you want to add type declarations as curried add function, add input is a number. What? Wait, what? Like, how do we know, like, the precedence of this one or this one, right? Like, all these arrows and parentheses are confusing me. So then we have, like, so this is the return, I'm guessing. Like, this might be, like, the outermost. So this one kind of takes precedence, right? This question popped up first in Google for how to return function, type return function for a function that returns a function. Add the generic solution. So you want to add type, create add function and number. So this thing. So this whole thing is to the input, and A plus B is the output. So you input. What? Just duplicate after the equal sign, make the return value the corresponding value. Export const add. Sure, I'm a bit confused. Livestream. Okay, so this is a plus b. That's fine. But what does this mean? So what I'm highlighting is a function, a lambda, which is input, takes in a number, and returns a number. So it's an input, so it's basically a number to number function. It's like f of x, like y equals f of x. So this is basically f of x, or f of a. So this is just a function that maps from number to number. So it takes that thing and returns a plus b. A plus b, where a is the the input to that one, and b is the output to that one. So if you have like if this function were like square, so like 5 and 5 squares 25, then add on, wait, what? This whole thing is a function of a? Which of these is like the so let's just say this is the input and this whole thing is the output. So now if you take in a, like, because first I was trying to make this make sense, but then this kind of confused me. So maybe like this thing is like the question's like, how do you do you group these first and then like do this is the outermost, or is it this? So I'm guessing that the leftmost, right? I think I was looking at it wrong because I was really, so let's say that this one, because I think like this thing kind of shows me that this one is the outermost, right? Whereas this one's kind of the more inner one. So add, so this add is a function, a lambda, whose input is a number and whose output is a lambda. So then a is a function whose so add is a function whose input is a number, so it takes in a number, and then it returns another function, and that function takes in another number, b, some different number, and then it returns a plus b. So that's currying, where we're currying the number a. So this add, so this adder, so we generated an adder where like if we do add of 5, that returns a number that returns a function which is adder 5, where whatever function we it returns a function whose effect is taking 5 plus that, right? So if we do like add of 5, like we can do add of 5 and 6, and that would return what? 11, right? So it's like that. So okay, so that's basically it. So the whole point is that the leftmost is like the leftmost kind of denotes as the input. Okay, good. So that's all I needed to know. That's it. But yeah, that's currying. So it's like, okay, yeah, I got it. Yep, that makes sense. So then here, what we do is like, and I think we use brackets to like kind of separate. So like this thing, everything in the brackets is kind of as one unit. So like this whole thing in the bracket kind of would presumably just kind of be a coin. So this whole thing in the bracket right here. Sorry, what am I doing? Lowercase v, capital highlights the whole line. So this whole thing right here is a function that takes in a coin, returns void, and that is basically the transform function, which transforms the coordinates of the coin, right? It's flipping horizontally in this case, but it could be flipped vertically. Like this coin.x, like this line right here, is basically like this lambda which you're passing in there. It's fixed point.sub, it's whatever. It takes in the coin and it transforms it in such a way that it like toggles its mutate its x coordinate. We could pass in coin.y here too, but that's it. So this stuff that's highlighted right here is in the visual mode is the transform function. So we pass in the transform function, and then we see the first left, like these are two arrows, but then the way that I'm guessing that we're kind of breaking it up, parsing it, is this one becomes like the outer one, just like how like this one is like the outer one. Like it's not like this is the input and that's the output. No, this is the input, and this so this is the input, and that is the output of the lambda that is add. So it's from left to right, right? So that's like the logic. That's my understanding from that. So our input is the lambda, which kind of takes in the coin and like transforms the coin's coordinates, and the output itself is like this arrow sign. So everything here till the end, or sorry, everything here. So this is the output. So the output itself is a function that takes a game state and goes to game state. So yeah, there's no need for this bracket then, these ones, just like that. So I think that that's good. So this is a function that takes in the lambdas, right? It's a function that takes in what? This thing? Gee, why do we have a bracket there? Let's delete that bracket. Or actually, no, let's just bring it back. Sorry about that. Yeah, we gotta wrap that in there, so then that's a coin. Wait, yeah, we have to bring in those functions back. Sorry about that. So this, right? It's gonna copy the whole thing, right? Like that. And this function here, let's just kind of take this, go there and just paste it, right? Like that. So this is the function here, which takes in the, so this function here, like the make transform function, it takes in the lambda of the coin transformation, and then what does it return? It simply returns whatever this thing is, right? Whatever is to the left of this arrow sign right here. Just like that. And that's what we return. So we take in the coin transformation function and we return this, and what we return is what I just pasted, namely this stuff. We return a function that takes in the game state and returns the game state. Good. So then what we do is we're letting, actually while we're doing this, let's just do return. Actually no, let's first let it, or first declare it. So we declare this transform function as a function that takes in a game state, returns a game state, and then first what we do is we clone it. Actually, why are you doing that? We can just kind of pass it in directly. Game state equals like that. So we start off with a current as just like a clone of that, and then for the number of game states, what we're doing is we are simply yeah, so now for coin of coins, what we're going to do is instead of this, what we're going to do is we're going to call this, or we have to give it a name, right? You know, we have to give this whole thing a name. Call this T for transform. So what we're doing now, copy that, to kind of change it from here. Just like that. Okay, so now the transform GameState function is a function called T. Wait, sorry. So this function here, right? So this function right here, this transform GameState function, its input is this. It's a function whose input is a function, and this thing, this input function, and it returns. So that's the input function. It returns the function that takes in a game state and gives you game state. So it gives you a game state to game state function. So the input function, let's dissect that, right? So input function takes in T, the transform function. The transform function just goes from a coin to, is a processes a coin, consumes a coin. That's it. Okay, good. So now what we can do is we can just kind of like do a T of coin to transform the coin. T of coin. Transformation function T. So basically we're kind of currying in the T, just like we were kind of currying in the A, to be an adder function that adds A to stuff. Right? Something like that, I feel. Like we're currying in the T onto this function here. Right? That's kind of like the idea. So okay, so then flip game state horizontally. Is it, so then we have to pass in what? Or let horizontally transform coin horizontally, which is a function that takes in a coin and it returns just void equals c.x equals like that. But instead of coin.x, it's c.x, right? Wait, no, this is wrong. This is wrong. This makes 0 sense. 2 equals. No, that's dumb. Let's just do inline. Let's do the function way. Hang on. I haven't really studied function currying since like CS61A, which I took in like 2011, 2012. So it's been over a decade since I looked into this stuff in Python. But yeah. So forgive my slowness. Transform function. I really want it to be nice and generic so we can just, it's more elegant that way instead of copying and pasting a bunch of nonsense. So transform coin horizontally is a function that takes in a coin. It's a function that takes in a coin. C dot x equals fixed point dot, fixed point dot sub. Just like this. Transform coin horizontally is a function that like takes in the coin, returns void. It's a function that takes in the coin. It sets its x to be the sub of the number of columns 20 minus itself. What's that? So make transformation function of that. Like that. So let's do the same thing for a vertical then. Transform coin vertically. Vertically. Coin. So coin.y. So now we're basically doing like, so this one we just like, that's horizontal. And vertically is obviously the same thing for y, but for num rows, right? So like right here, it's like this coin basically from here to here, right? So this coin here goes to this one, right? So here what we do is like you kind of take this one here and then you do that one. So this one is like some delta here, which is the y, then 15 minus that to get there. And then from here to here, same thing. If you have like, if this is like 12 and like that's 3, then 15 minus 12 is 3, that's perfect. So that's just the dual, like the same the other direction, right? So that makes sense. So vertically just y, and that'll be num, then like make them both y's, and do num rows for 50 rows, right? Just like that. So now what we can do here is call this vertically. Vertically is that, but then now we kind of do that. Just like that. And then we have our final transformation. And again, these transformations are only from GameState to GameState. We also have to consider the policy arrows too, which I might think I'll do next stream. So I just want to make this compile and then exit out of here. And then what we need finally is a new transformation, which is transform horizontally and vertically. Horizontally and vertically. So rather than kind of copying, I can be super fancy and do kind of call them both, just to show that like just to show that like the order doesn't matter. It's commutative. Like you can transform h and then v or v and then h, but the side effects are just kind of an x coordinates and y coordinates. Like for a given coin that's going to be transformed, at some point its x has to be transformed by flipping from 20 minus x. and at some point its y has to be transformed from 15 minus the y. Like, it doesn't matter the order, but that's like the end effect that's desired. And this is exactly the two operations that are to that end. Coin. So transform horizontal, like takes in a coin and returns a void. It consumes a coin. It's a function of a coin. Same thing with that one vertically. So we first transform it horizontally, then we transform it vertically. There's like so many chaining that makes, yeah, it's pretty cool. Just like that. And that's all. So transform. Like that would be the game state to game state is make transform, but then now rather than doing this one, we have to kind of do that. Yep, like this. Okay. So this is the general make transformation like helper function or generator function or factory function, whatever. And it just like, no, generators are for iteration. There's something else, but it's like a factory function, like some, and we just pass in the coin process. Okay, I think this, I mean, at least the logic is there. Now let's see it. Let's just cross our fingers and hope that this compiles, right? Okay, oh no, we have to do it for symmetry. Nope, errors. We have to import coin. Okay, that's an easy fix. Okay, so there are some bugs. 56, clone the game state card. Okay, let's look at line 56. F 56, clone the game state. Oh, I see the problem. Right. That's a good catch. Let's transformed, let RTN equals, or let transformed game state equal that. Ah, oops. Just like that. Okay, I did a lot of like kind of typing. I hope that, I mean, lots of like coding. Well, not a lot, but like a lot of like untested stuff. So I hope this works. So let's see. Transformed game state. We kind of, so like, we're kind of like, so this, we're cloning the original game state and we're going to like return this one right here, right? And then like this pointer, we don't want to return car clone. Like the suggestion it gave me was, do you want to return this? Absolutely not, because like the car cloned, like it keeps getting reassigned to like the previous ones. So like we have to like kind of save a copy, like a pointer to the original one, and then it's okay to change this. But like we have to save the head. right? I have to save this like root, basically. So I think that's good. Ah, yes, I have to make that a fixed point. Got it. Got it. That's fine. Oh, nice. If we reach these things, that means that this whole thing was okay. That's wonderful. Fixed point dot from. Wait, hang on. Less GameState dot ts. Okay, I have it. That's what I thought. That's what I thought. That's exactly what I thought. Just gonna copy it from there. Hey, would you look at that? Here's a logic for doing it. Fixed point dot sub from that. That's exactly the same logic. Yeah, let's just be super kind of precise and be a very yeah, let's just be very kind of like let's not repeat ourselves, you know? From number, not 20. Surely we didn't mean 20. What we actually meant was GameState.num calls. Very, very professional, right? And now where's, yeah, okay. Calls. 20. 20. 20. Yep. Again, 20 should not be there. Let's make it GameState.num calls. I could define and replace, but it's very few occurrences, right? Just these two. I think that's it. Yep, that's all. But anyways, the whole point is I was copying this fixed point dot from number. So it's not GameState.num calls because that's a number. We want it to be fixed points. We want to do it from the number. Exactly. And same thing there. From number, so you're wrapping it in as a fixed point. Num rows. And then dot y. Okay, that looks good. Clear. Nice, it compiled. Okay, get status. Get diff. Okay, so get diff. Wait, what? Clear. Get diff. So, oh, because we haven't we haven't like added, yeah, so like it's only showing us the differences, but like symmetry is a new file entirely. So let's look at the changes for GameState. GameState, we deleted this energy nonsense. And then for mirrored, rather than 20, we're kind of like using the number of columns, which is 20. And same thing there, rather than this 20, we're replacing it by like number of columns. So that's completely fine. And then when we're doing cloning, we also have to copy the whose turn is it? And we have to also copy this. Now, yes, we're not actually like deep cloning. Like we're actually like here, we're just kind of like preserving the pointer. We're not actually like cloning this one recursively. No, because I mean, yeah, we're not. That's just the way it is, I guess. Yeah, this whole historical business is just a bit of a hassle, but oh well. And then for neural net, instead of just like letting it be 2, we're just kind of like exporting it to so that symmetry can use this variable. That's all. So get status. So we have looked at the changes in GameState and net. So we've kind of like looked at these two, and then the symmetry file, yeah, it's a new file. And we tested to make sure it compiled, so that's good. Get status. git commit initial untested work on symmetries for GameState transformations. On symmetries. GameState transformations, or yeah, for GameState transformations. Initial untested work on symmetries for GameState transformations. Status, and I'll push this off stream, but yeah, like I think that this is, yeah, the main thing right here is just like less symmetry TS. Basically like this is the same from Connect 4. This is the abstract, just like a generic high level, top level symmetry class. Everything is in terms of policy and game state. And the actual details, like the identity is pretty simple too, leveraging the clone functionalities that we have, game state clone and policy clone. The only kind of fanciness right here is like this factory function here, which kind of generates it's a make function that in turn like takes in the transformation function, returns a function that kind of uses it here. And then then we like kind of do horizontal and vertically by just kind of subtracting the respective lengths of the board with the pertinent fields that we're kind of mirroring, flipping. And then for doing horizontally and vertically, the transformation is very nice. We simply chain both of these, so it's like a nice chaining of them. So everything is kind of really neat and tidy. And then these flip functions, rather than kind of copying and pasting all these lines, we're simply kind of writing it once and reusing it a bunch of times. So I think that's pretty lofty, or pretty, yeah, that if it works, it's pretty nice stuff. So yeah, I think that's all for now. I mean, right now, basically, in theory, if everything is being done correctly, then like these coins have been done, and now the next step, which I'll do next stream, I guess, is like the arrows, right? Like making the arrows work. And I think it's gonna be I mean, yeah, we'll see, but yeah, maybe there'll be some similar factory, some make other function too, which could be used. But yeah, this is basically this is how we transform the coins. At least we basically kind of use this function, like these two functions, 20 minus x and 15 minus y, to go from y to y prime and x to x prime, where x and x prime are like the coordinates that we care about. So yeah, that's all for now.